Okay, thank you, Maria. Thank you for the invitation. So, I'm going to talk about patient data and stratified medicine, opportunities and challenges. And I'm going to begin with a couple of quotations from two of the Western world's greatest minds. And what we've heard today is that we've now got biologic therapies, very expensive therapies. We want to be able to target those to the individuals who are going to get the greatest benefit. And that's something that's recognised by patients, of course, by physicians, and of course by the pharmaceutical industry. But it's also recognised by the first great thinker, which is George Bush. And his take on this is, excuse me for this direct quotation, but it is a direct quotation from George Bush, who also gave some thought to this particular issue, where he said, get this to move, drug therapy is replacing a lot of medicines as we used to know it. So just bear that in mind. So if there's anything else you remember from my talk, the other great mind, of course, was, and he's always ahead of us in everything that we think about, is Hippocrates. This is his take, and this is absolutely a very accurate one, on stratified medicine. It's more important to know what person the disease has than what disease the person has. And that's what we're talking about in the course of the day. So I'm going to discuss a little bit about the SORT consortium, because it has relevance to what we're talking about, and also Psoriasis Stratified Medicine Consortium, how we get data from registries and clinical trials, and how we put that together within a TranSMART data warehouse. This tsunami, if you like, of big data, and whether that's really going to be helpful to us, and how we can interpret data using machine learning, and the opportunities around e-health. And then close talking about how patients can increase the knowledge in their general communities about the opportunities around taking part in research, and of course in stratified medicine, citizen scientists and patient and public involvement and engagement. So SORT is psoriasis stratification to optimize relevant therapy, and I'm going to talk a little bit about that in the next few minutes. So psoriasis is a common disease. Over 2 million people in the UK have psoriasis. It is without doubt a heterogeneous condition. Currently, we have no cure for the disease, and it is, in many patients, life-ruining. It doesn't kill many people, but it ruins their lives, and it's very important that we think about the effect that diseases have on individuals. And we've made tremendous progress over the last 10 years or more with understanding the disease mechanisms and then using modern technologies, drugs, to target those to improve the quality of life for those patients. What we do know that in patients with moderate to severe disease, the introduction of biologic therapies, whether the anti-TNF or anti-R1223 or the new anti-R17s, have been transformational for their lives. Not only has it been transformational, we also know, this is where it's relevant to stratified medicine, there's a variability in response of individual patients, not just in the short term, but in the long term, to these biologic therapies. And that's why, as I'm going to show you, I think psoriasis lends itself very well to the MRC Stratified Medicine initiative. I don't need to tell you this, but if all of you in this room have psoriasis and I had a biologic therapy such as etanercept, I wouldn't know by looking at you as you sit here in your seats which one of you was going to have a very good response to the drug, who wasn't going to respond, which few of you were going to get side effects. That's the current situation. So what we want to move is a sort of trial and error approach to a much more targeted approach to the management of psoriasis or any disease. And these consortia, as they're put together, had two important components to them. A is that they were going to be milestone driven, so very industry sort of take on this. So you couldn't just get all the money up front and then expect us to come back in 4 years' time and tell the MRC what a great time we're going to spend £5 million. You had to apply for that, in a way, that money on an annual basis with a rigorous review, which is the right way to do any research. But also, very importantly, industry will engage from the very beginning. Because translational research is not just seeing the clinical opportunity, developing the science around that opportunity, it's also the commercialization of that science, which is stratified, and that's where industry has to be involved. So you could use this for for any disease. So it's phenotype, it's genotype, the biomarkers. If you move from the affected population through to disease phenotype, you come up with biomarker validation and stratifies. So it begins with a very heavy academic load, finishes up with the partners, the commercial partners, particularly diagnostic companies, that take you through the evaluation of the stratified clinical practice. So psoriasis, I would say this one day, is a good disease for stratification. It's common, over 2 million people. Biologics are used as monotherapy. It's not like rheumatoid arthritis where they're used in combination with methotrexate. The response to therapy is simple to quantify. We can see the disease. That is the huge advantage that we have with most other diseases which are being stratified at the moment. So we can ascertain response. Also, we can very accurately assay the disease tissue by skin biopsy. And this ability to do the skin biopsy is something that we talk to patient groups about as we were developing the application. First of all, we went to the Psoriasis Association, it's the representative organisation in the UK now, and asked them if we could develop a stratifier. Is this something you would be interested in? Yes, we would. We don't like being pushed from one drug to the next until we find a drug that works best for us. We want to become the right drug for us first time. We then asked them if we were going to do this, would you accept not just having a blood test, but maybe we could do a small biopsy and actually get very accurate information from the skin. Would that also be acceptable to you? Now, currently, for our research work, we use 6mm punch biopsies, that's 6mm diameter. That requires sutures. They said, yes, that's fine, but we'd much rather if we could do it with a smaller biopsy, which didn't require sutures. So that'd be a 2mm punch biopsy or microbiopsy. So the challenge they put out to us is that can you get the same amount of information from a very small 2mm punch biopsy that doesn't require sutures that you can from a 6mm. So that's something we took forward within our application. So that's why they were so important, again, from the very beginning. And our hypothesis was that can we use clinical genetic immune biomarkers to predict and reproducibly stratify responses to psoriasis to biologic therapies that's minimally dosed, which was my question to Ian earlier, and also that we could develop an algorithm or stratifier that would be suitable for clinical use. So it's not just a single biomarker, it's going to be a whole host of information, and that's where this data becomes very complex. So actually, to make that decision whether the patient's going to respond well or not respond well, is the cost utility greatest if you can use the stratifier. And importantly, whatever you find has got to produce healthcare savings. The NHS are not going to be able to cope with this if it doesn't produce healthcare savings. Why is it important? Well, it's important particularly to industry because you're going to come up with a new taxonomic classification of the disease, and that would be the same for lupus as well, or any other disease. In fact, same as you're using for primary biliary cirrhosis. It's actually going to be a whole host of different conditions, probably determined by these biomarkers. The stratification tools will allow or facilitate accurate targeting of new molecules to a patient to a drug at a time. Establishment of minimal effective dosing, so we can use less drug. And then also for us in psoriasis, it's advantageous because we're using some of these new biologics for the first time in psoriasis ahead of inflammatory bowel disease or rheumatoid arthritis. So it's nice for us to be informing those inflammatory diseases as much as they've informed us over the past several years. So these are the collaborators. Obviously, the MRC we view as a collaborator. They were very helpful as we put together this whole applications consortium. But we have academic partners. We have the Psoriasis Association. We have 10 industry partners, 7 pharmaceutical companies, and 3 diagnostic companies who initially won't be too involved. What we'll do as we move forward. The idea of microbiology first. The work strands, a little bit of detail. The key thing about work strand 1 is that we're assessing adherence. Because the main reason that people don't respond to drugs is that they don't take them. All of you in this room, I can guarantee, will not have taken a prescription of antibiotics for the length of time that you were asked to do that. I'm very surprised if you have. Certainly using topical medications, most patients don't use them twice a day, they use them once a day. So that information around adherence actually is a different sort of set of information. It's not hard quantitative biomarker data, it's psychological information. because psychology plays an important role in whether individuals go to adhere to treatment or not. And those are going to be very useful as you take your algorithm. And then taking those biopsies from the skin and looking at transcriptomics. So this is the sort of plan we have. So this is a dynamic platform. These two are not single work strands, they are integrated. We're looking at response. So we're going to go through a discovery phase. We're looking at response to anti-TNF, ustekinumab, another biologic called secukinumab. And then we're going to refine it using that microbiopsy technique. And then we're going to validate it. And that's where the sort of data starts to get very complicated. So we're going to validate it, something called bad beer. It's not a poorly performing brewery. It's actually a resource that we have in British Dermatology, the British Association of Dermatology Biologic Interventions Register. And it's probably one of the main reasons that we were awarded the SORT consortium, because we had real-life data on patients. This is not clinical trial data, which of course is very important, but if you looked at this with real-life data, 30% of those patients in the registry, for various reasons, would be excluded from the clinical trial. And it's probably about 30% where the problems, the risk, the important risks that underlie. So we set this up about 8 years ago. Found in 2007, first patients were admitted. It's web-based. It's now felt to be the world standard for a registry in psoriasis. We have 152 dermatology centres around the UK who are contributing to this. So these are not just big centres. We've seen a lot of patients on biologics. These are small centres as well. And we only have 4 or 5 patients on biologics. But again, that may be where the risk lies. But importantly, in the context of stratified medicine, we're collecting phenotype, quantitative disease severity data. So this is set up as a safety register. We're looking at response to therapy as well. So we can start to get information that's going to be very important when you start to stratify patients according to disease and response to drug. And even more importantly, more than 30%, and that's increasing all the time, are biological data that's been biobanked. So DNA and serum samples. So we start to build up a very powerful resource to validate this work. Currently, just as about a week ago, we had over 11,000 patients in this registry. I'm going to go into detail there. This is the sort of information you can get, so it's very detailed information, which is going to have relevance to stratification. Do they have psoriatic arthritis? Is there a history of cardiovascular disease? What is their BMI? We already know that people who are overweight, about 30% of people with psoriasis have a high BMI. That dictates response to some extent to the anti-TNF drugs, because that has to go into your stratifier. We know the proportion of patients on these different biologic therapies. We're also looking at patients on systemic, conventional systemic therapies. You can start to see here that patients have impaired quality of life. DLQI is Dermatology Life Quality Index. And so they have that goes from 0 to 30. So impairment of quality of life is anything over 5. So these are significantly impaired in their daily activities. They are not able to lead what we would call a normal life. And you can see here, average BMI is over 30. But already we can get data from that biologics registry, which is going to inform stratification. So here's looking at persistence on therapy. So ustekinumab is an anti-IL-12, IL-23 biologic. Etanercept and infliximab are anti-TNFs. You can see on the left-hand side of this forest plot, ustekinumab is the one that has the best, is less likely to withdraw from therapy. Those patients who are female, they're smokers, maybe on concomitant methotrexate or on infliximab, are much more likely to withdraw from therapy, much less likely to persist on therapy. That's important, of course, in stratification. It's not just short-term, this is long-term information. Industry have been fully engaged with this. This is an example of how the industry have been engaged and how their information is going to inform what we do. So Signature is a trial that's run by Novartis, studying an anti-IL-17 new biologic called secukinumab, just been licensed in the NHS. And they actually agreed, even though they'd set this study up, to have 50 patients within that open study who would be SORT patients. They would have those biopsies on a sequential basis, they'll have the blood test taken, they'll have DNA on all the patients, and that we could use that information. Obviously, it then had to be married to the clinical outcome data, and you can imagine the complexity that we've had. This IP is a major issue when you're dealing with 10 companies. Some writer who's a program manager sitting in the back there has had a pretty arduous year dealing with these companies, and dealing particularly with American lawyers. Because you know things are going to get tough when you get the American lawyers on the phone. But we've managed to find our way through. And I think doing this work, setting up this consortium, what the MRC is, yes, they want to see the science, but they want to see how we manage it and how we deal with these very thorny issues which don't get talked about very much. I'm going to go into detail on that. So all this information that's coming in, and Mike Barnes sitting in the back there is the guru who is working with a company called Anthony from Janssen, is that all this information, how do you store it, how do you make it accessible? Because it's clinical information, it's biomarkers, immune biomarkers, genetics, maybe it's psychological information as well, all coming in. How are you going to store that? So it's a very sophisticated setup called the SORT TranSMART, in this case. TranSMART system is a data warehouse. But you can see that on the right-hand side there are other MRC consortia, such as Matura, which is the Rheumatoid Arthritis Consortium, which are utilising the same system. So it's a sort of system that's now being sort of accepted within this sort of area of stratified medicine, and it could well be in time to share information with those other inflammatory diseases, because there's commonality of rheumatoid arthritis, there's commonality of inflammatory bowel disease. We shouldn't just be bunkered in just because psoriasis, we can learn from other diseases. So with SORT, we have data coming in from the studies which have been done prior to SORT starting. So a study on the etanercept, that signature study I talked about, with all the complexity of clinical trial data. There's other industry partners data coming in, data sets which have been paid contribution in kind from industry. And then there's information from bad beer. And that's actually had to be a whole separate arrangement between bad beer and SORT as a data access plan, so that we could access that data. Even though I direct both, and I still had to write a letter to myself if I could get agreement with another data to be released. And then you can then populate this with publicly available data from papers which have been studied, have been published by others. So we can start to build up that database from external sources, and then that can then be used to then start to analyze the data coming out of those different work streams, whether it's transcriptomics or genomics or metabolomics. And of course, part of it is a data access plan. You've got to have pretty rigorous guidance as to who can access the data, because a lot of this is confidential. The companies are putting this data in, and you can imagine that there's IP that might reside with that. So there's going to be, there's the curated public data which is available to all. There's the background data which they've put forward, which they've allowed us to use. And then there's the SORT data generated by the consortium, which goes through quality control. And then you get the SORT consortium quality control data, and then it's accessible after the executive has approved it. So you can see you've got to have these very detailed access plans in place. And the management structure reflects that. As you see on the top right-hand side there, there's a separate committee, which is around patients and their members, who feed in to our steering committee. Very important. There's this member of the patient group that sits on the steering committee. There's an industry group, which also is separate, that feeds into the steering committee. And there's a commercialization and IP management group. And that I can't emphasize enough how important that IP and management group is, because that's where your problems lie, and that's where the deal breakers can occur. Because if a company's going to not accept the IP arrangements, they get in trouble. So that's all around psoriasis, and that's sort of using that as an example of how complex it is. And you'd have seen also in that, maybe you saw in that diagram I showed you, the way we can analyze this data is with something called machine learning, which works with patterns of the data. So everyone thinks that big data is the answer. We talk about big data, big team, all that sort of stuff. So there's no doubt this is like a meteorological forecast here. So you've got a tsunami data, huge amount of data. You think about the data that we're all generating in this room, the different consortia we're involved with. That's the part. But also there's lots of data coming from small studies, observational studies, many of which are not reproduced, which are still still useful if you can analyze it. But the problem is, we don't have enough people in this country who have the expertise to do the analysis. Health informaticians are like could well be like strikers in football. They are a desirable commodity. But we need them because we can't do anything with this data otherwise. But what we can do is, if we do get those individuals, they can use sophisticated techniques such as machine learning to start to generate hypotheses from that blizzard of data. So rather than having sort of the ideal, which is big studies and big populations, you've got to be able to do something with all that data that's out there. You can't just ignore it. I'll give you a couple of examples of this. So endotypes, you've heard that phrase a couple of times now. Endotypes are subtypes of disease, first developed in the asthma field actually, subtypes of disease which are functionally and pathologically determined by disease molecular mechanisms and or response to drug. The drug response of disease. And those are the foundation of stratified medicine. We're looking for these patterns in endotypes. And asthma is a good example. I can actually put psoriasis up there. I could probably put Crohn's disease up there as well, rheumatoid arthritis or lupus. There's a heterogeneity of disease in there. We're not hidebound by those old-fashioned ways of describing disease. There's much more to it. And so with asthma, it's a good example where we can just start to generate hypotheses using machine learning. And my colleague Ian Buchan, who's loaned me some of these slides, his view, he has an interesting take on, you've heard him talk, it's an interesting take on all these things. So he views, he doesn't like the term mining here, but he views that you're just looking at the problem, which is this sort of heterogeneity disease. You're only looking at a very small part of it. He talks about looking at it through a prism or doilies, and just picking up small parts to try and come up with the whole answer. We've got to have a way of assessing all of the information. So here's an example from Manchester. So we have a birth cohort of 1,000 children in Manchester who've been followed up, particularly for Autum. So this is run by Adnan Kustovich and others. And what we tend to do in medicine at the moment is over-aggregate. We tend to lump rather than split. In fact, with stratifying, we should be splitting. So this is taking these children, just using an indirect test of sensitization of atopy, either prick test or blood test, and following years, ages 1, 3, 5, and 8, to see whether they've gained or lost sensitization. And you can then start to assess that using machine learning. And what they found is that you're not just atopic or non-atopic. Actually, not too surprising, it's much more complex than that. They can be non-atopic, but they can be atopic using non-dust mite, dust mite, multiple late sensitization, and multiple early sensitization. So already it's starting to give you a different view of what atopy or asthma is all about. The other thing they were able to do is that the received wisdom at the moment is something called the atopic march. You develop eczema, then you develop asthma, and then goes to rhinitis. So therefore, preferentially, you should be following up those children with eczema to screen them for asthma. And that was documented and set in place about 12 years ago. But using machine learning, you can start to re-look at that data and see if that is really the case. And what they found is that was actually a fallacy. So the atopic march in this sort of cohort, not just one cohort from Manchester, but cohorts of other children in other parts of the country, if you looked at that using machine learning, the atopic march only held true for about 3% of those children. So that's probably, so that is debunking that dogma. But you can only do that with a sophisticated interrogatory methodology. Other people say, well, what about all this data that we're collecting from electronic patient records? In Salford, we have a very sophisticated electronic patient record serving a population of over 200,000. Do you need clean clinical trials to show you data, to show you the way forward? And probably not. If you've got a way to analyze it, you can develop the tools to actually analyze the data that's coming forward. This is an example of looking at liver enzymes in patients in Salford on glycosone or on any other medication. And you can see that when they go onto this anti-diabetic medication, their liver liver function improves. You can show that then without this sort of messy primary care data. You've got the tools, you can analyze it, and that's real world. I think that's what's very important. Also, at the University of Manchester, we had our informatics group span out a company called FARSITE, called Northwest eHealth, which then supplies software to allow clinical researchers to recruit using electronic patient records. So here, if you're doing a study on asthma, you can put in what you want. If you want women over the age of 40 with asthma and other, maybe eczema as well, how many patients do you have in the Greater Manchester area? These are the ones that we can target, but maybe a new drug from UCB or whichever company. It gives you much better accuracy when you come out to predict whether you've got patients in the population that you can target these trials. And also, you can use these electronic health records. Let's say do it in Salford, where we have one hospital, 53 GP surgeries, and an integrated care record. And using sophisticated software, you can start to track the patient journey. So you say, okay, interested in those patients who've got chronic kidney disease, they've got terminal illness, you exclude them from the analysis. But then you exclude if target is achieved, so they've got control of blood pressure. And if their blood pressure is not controlled, those GPs will get a signal, get a message saying that 16 of your 109 patients on chronic kidney disease, as fast as possible way, be better managed because you haven't checked their BP in the last year. So the people doing this work don't know the names of these patients. That's totally irrelevant. They're just looking at the data. It allows those patients to be managed better. Patient journey is getting complete. And then consent to consent. I think all of us are involved in that now. When we set up the Academic Health Science Centre in Manchester, the citizen scientist concept was quite new. So this is where people in the local population, in this case in Salford, become ambassadors for clinical research because they can tell their families. They know what research we're not saying to do for them. It might help their families and their children's families to benefit. So patients coming into Salford have the opportunity to say, yes, I'd be interested in a clinical trial. Send me the information if it's relevant to me. And we're going to do this now with psoriasis patients as well, because we're only capturing in Manchester just a very small percentage of psoriasis patients. We could do far better than that. And that would also play into our SORT consortium, which has been extremely well received by patients in Salford, the European population of Salford. And the other thing that we've done, which we enjoy doing very much, is going out and talking about psoriasis. So when we launched our SORT consortium a year and a half ago, we decided we'd have a whole week long in Manchester on events around psoriasis. Everything from a fashion show at the Trafford Centre. If you really want to see me dancing, you can go onto this website here. Probably not something I'd recommend a stiff drink. And what we did was go out and tell people, the general public, what psoriasis is and what it isn't. Very important. But also tell patients about stratified medicine, tell them about the new treatments that are coming forward and how participating in research will really make a difference to people who come after them with psoriasis. And we're going to run it again. That was in Manchester. We've not done so much this year. We were visiting last week. But we're going to have a much bigger event around the country. So all of you can take part in a year's time. So what I've hopefully done is show that stratified medicine brings huge opportunity. It's working closely with patients doing both the planning and the delivery of the stratified medicine agenda. These multiple sources of data are immensely complex, and that's why you need a TranSMART data warehouse just to store it, to then analyze it. And that real-world data, although it's very messy, is actually highly informative if you've got tools such as machine learning to interrogate it. And that's very important. I think that's probably an important message that I've heard. 2 years ago, I'd never heard of machine learning. Now I realise that's really the key to unlocking this. And there's need for more expertise in health informatics. There's no doubt about it. We need to have more people who are capable of developing these technologies to allow us to assess all this data. So thank you.